This is lesson 65, which would have been Friday, the 20th of March in the morning. This is what I would have given you there. Okay, in the morning session. Okay. Yeah, okay. So it's lesson 65. It's page 458 of your textbook, simple root finding. Okay, so a root is a solution to an equation. Okay, and if we've got an equation, so I'm here, look, such that f of x set equals to 0, the x coordinates of the points where the graph of y goes, so it's where it crosses the x-axis is the solution. Okay, so let me just draw a little picture of that for you. So there, this is the graph f of x, this is the curve, these the x-axis, the y-axis. That point there, that's a root. Okay, and you might have more if it comes back like this. These are roots as well. Okay, so we've set f of x equals 0. So sometimes we do know some ways to find roots, like the quadratic equation or solving linear equations, or the sine inverse button on your calculator, the trig inverse buttons can help, but sometimes it's difficult or impossible to find the exact value. So what we need to do then is use a numerical method to estimate the value. And the simplest numerical method for detecting a root is the change of sign method. So if we've got two numbers, if you've got f of c and f of d, so two numbers c and d, when you evaluate f of c and f of d, if one's positive and one's negative, and it can be either fc could be positive or negative, but the other one is the opposite sign, we say it changes sign, and that means if it's going from positive to negative or from negative to positive, it means there's a root between c and d. Okay, so I can draw you a graph here. So there's the root. It's a bit like what we've done already. Okay, if that's C and that's D, yep, so f of C is negative. And then D, f of D is positive. Okay, because it's above the axis, below the axis. Along there, if you remember the x-axis, y is 0. Okay, so above it, f's a positive, below it, f's a negative. Okay, so since the curve joins P, which lies below the axis, so they call that point P, and that point Q. So it joins P below the x-axis to Q above the x-axis. The curve crosses the x-axis somewhere between C and D there. Okay, because it goes from P to Q, negative to positive. And this is the point R for root, I guess, and it's alpha 0. Okay, that's alpha there. That's just notation. So alpha is just the value of x that makes the function 0. And alpha is called the root. Okay, this is really easy in practice. So f of x is a continuous function. The reason they've put continuous there is because there's no breaks, so it's definitely got to cross the axis, the x-axis. It's got exactly one real root alpha. By continuous, it means there's no break. So if you've got above and below the axis, a positive and a negative, it must cross it. It can't just be like, because it jumps without break. Okay, so show that alpha, this one here, I'm here, part A, show that alpha lies between 2.35, 2.45, and then state it correct to one decimal place. So we've got f of x equals x cubed minus 4x minus 4. And if we've got f of x equals 0, that means x cubed minus 4x minus 4 equals 0. And that's what we want to find. So A, we look at f of 2.35 and f of 2.45. And f of 2.35 is 2.35 cubed minus 4 times 2.35 minus 4. And on my calculator, I've got that as minus 0.422125. F of 2.45 is 2.45 cubed minus 4 times 2.45 minus 4. And I've got that one as 0.906125. So f of 2.35 is less than 0. F of 2.45 is greater than 0. So therefore, the alpha, which is the value that actually makes it 0, lies between 2.35 and 2.45. It's less than alpha, it's less than 2.45. Okay. So if we think about this with our diagram, these are x here. Oops. 2.35, 2.45. This one's negative, so it's there, and this one's positive. So alpha is between the two. Okay. Right, so this is part B now. State the value of alpha correct to 1 dp. So all the numbers, numbers between 2.35 and 2.45, all of them there'll be things like 2.36, 2.37, then right up to 2.45, not including the 4.5, all of them will round off to 2.4. to 1 dp. Okay, so therefore alpha is 2.4 to 1 dp. If we actually put 2.4 in, I don't know what we get, I haven't done that on my calculator, but yeah, it'll be close to 0. It's not, it won't be exactly, but it'll be nearly there. Right, so next page at the top here, it tells you there's an exercise to do on page 459. So you can look at that, do some of those. Example 2. Use a sketch to show that the equation 2 to the power x is 4 minus x has exactly one solution, alpha. Show that alpha is 1.4. Right, so for this sketch, this is A. For this sketch, 4 minus x, that's going to be a straight line graph. So that's going to be 4 there, because when x is 0. There we are. It's a straight line graph with a gradient of -1, and it will go through 4 on each of the axes. This is the line y equals 4 minus x. As you think x equals 0, y is 4. If y is 0, well, x has to be 4 to make y 0, because 4 minus 4 is 0. And now the curve of 2 to the power x looks like this. Okay, so there's only one solution. They will never cross again. One solution only. Okay, I'll show that alpha is 1.4 to 1 decimal place. So if we've got 2 to the x is 4 minus x, first of all, to use this method that we've detailed on the previous page, we need to have the right hand side equals 0. So we can say x minus 4 plus 2 to the x equals 0. Okay, so this solution here, whichever value this is here, it will satisfy this because it's where 2 to the x equals 4 minus x. So if we rearrange this, add x to each side, take 4 from each side, you'll end up with 0. Okay, on the right hand side. So we call our f of x, x minus 4 plus 2 to the power x. Okay, and then we do, now if it's 1.4 to 1 decimal place, we need to look at 1.35 up to 1.45 because those values are going to round off to 1.4. This is part B. Let me just put a line here because it's sort of overlapping a bit now. Getting a bit messy. There we are. Right, f of 1.35. Run that through your calculator and it's minus 0.1. f of 1.45 is 0.182. So there's a change of sign, which is what we're looking for. So therefore, and that's the alpha. That alpha there lies between 1.35 is less than alpha is less than 1.45 because of that change of sign. Okay, that's the answer there. It's this change of sign that we're looking for. Set this equals to 0, so f of x is equals to that. Example 3. F of x is 1 over x minus 2 and x is not equals 2. Show that f of x changes sign across the interval 1 and 3. So A, f of 1 is 1 over 1 minus 2. So it's 1 over minus 1, which is minus 1. F of 3 is 1 over 3 minus 2, which is 1 over 1, which is 1. So there is a change of sign here. But this doesn't actually mean that there is a root between these because the actual graph of 1 over x minus 2, it has an asymptote at x equals 2. Oops, it's a bit weird. Because 2, if we've got f of x is 1 over x minus 2. If you've got x equals 2, it's undefined because that would lead to division by 0. So that's why we get the asymptote there. Okay. And so when x equals 0, y is minus a half. Because if we put 0 in there, it's 1 over minus 2, which is minus a half. To find the horizontal asymptote, we can say as so for the horizontal asymptote, we need to know, I'm trying to think how I explained this before, got y equals 1 over x minus 2. The way that we do this is we get an x equals instead, rearrange it. So it's y times x minus 2 equals 1. So x minus 2 is 1 over y. So x is 1 over y plus 2. And what we do? As going to quickly this 1 over y, this means that the 1 over y, sorry about this, the 1 over y there, we can't divide by 0, so that means there's a problem when y equals not is equals to 0, so the horizontal asymptote is along y equals 0. Okay, so sorry for the pause there. To explain what I did then, we rearrange it. To get the x asymptote here, it's x is 2, because you can't divide by 0. And if x is 2, then we've got division by 0. To get the vertical asymptote, well, this is, if you've got y equals 1 over x minus 2, that gives you the horizontal one. So you rearrange it to get x equals. So rearrange this, like I did there. Look, the problem there is when y equals 0. So I'll put this in another colour over the top here. I'll do the asymptotes in blue so you can see them hopefully. Maybe. This is an asymptote too. And then the graph looks like this. Okay. So back to the sign change. So 1 is this side, and that comes up as negative. 3 is this side, and that comes up as positive. But there isn't a root because it's not continuous. Okay, so there's no roots. So just because there's a sign change, it doesn't guarantee that there's a root. If there is a root, there will be a sign. There will be a sign change. But the opposite isn't true. The converse isn't true. Okay, so it's no roots, it's not continuous at x equals 2. Okay, so if you think there's a root, you need to go and double check what the graph looks like. Okay.